Dear students, now I am going to discuss the topic vector differentiation. So in this topic, differentiation of the vectors come and partial derivative, the partial differentiation also. So combining both in a university question paper, you will get two complete questions. That is, in this is the one concept you can attend, you can score 40 marks. So just I will discuss what is the vector differentiation and what are all the concepts comes under this topic. Let us consider a vector R is equal to xi plus yj plus zk, where R is called a position vector. This is the important, the vector that is, this is the basic vector we will consider. R is equal to xi plus yj plus zk. Now if I differentiate with respect to t, then this denoted as dr by dt. So if we consider if we consider t as a point, then if t as a point, then dr by dt, the derivative of r with respect to t gives a tangent, slope of the tangent denoted as t. Whereas if I consider t as a time, then the same dr by dt, that is a differentiation of r with respect to t, rate of change of r, that is the position of a particle with respect to time, is denoted as velocity. So same dr by dt, if you differentiate r with respect to t, you can find tangent as well as it gives velocity, the same formula. And differentiation of velocity, dv by dt, or this is same as d square r divided by dt square, that is the double differentiation of r with respect to t, d square r by dt square, that is equal to dv by dt, because v is nothing but already v is equal to dr by dt. One time already we differentiated, so another time, so d square r by dt square, this is denoted as acceleration, rate of change of velocity with respect to time. This is the application of this vectors. Now here what type of the problem they will ask? So they will give directly r is equal to, or they will give x, the value y and z, that is called parametric equation in terms of small t, and they will ask the question, find unit tangent vector or angle between two tangent vectors. So like that you will get the question in the exam. So unit tangent vector, as I explained in the previous topic, whatever the vector you take, the formula of unit vector is equal to vector A divided by its magnitude. Same way, unit tangent vector t cap is nothing but vector t divided by its magnitude. So similarly, if I want to calculate the angle between two vectors, that also we discussed, angle between two vectors A and B, that is cos theta. Cos theta is equal to vector A dot vector B divided by magnitude of A into magnitude of B. This is the basic formula, and for this formula just you replace, instead of A and B, it is T1 and T2, that is T1 dot T2 divided by magnitude of T1, magnitude of T2. Let us discuss these concepts with some examples. Let x equals t square plus 1, y equals 4t minus 3, and z equals 2t square minus 60. Find the first question, unit tangent vector. Second question, angle between the tangents, at t is equal to 1 and t is equal to 2 at the points is given. The first we have to consider the position vector. Let r equals xi plus yj plus z k. So since they are given the parametric equation for x, y, z, so r equals t square plus 1 I cap plus y 4t minus 3 j cap plus z 2t square minus 6t k cap. Now first we have to calculate unit tangent vector as well as in the second question angle between the tangents. So anyhow, tangent we know that the formula of t is equal to dr divided by dt. That is the differentiation of r with respect to t one time. So differentiate with respect to t. So LHS denoted as dr by dt. So that is equal to, this is nothing but tangent vector t denoted as t, and differentiation you will get t square differentiation is 2t, differentiation of 1 is 0, so 2t I cap plus differentiation of 4t is 4 minus 3 0 j cap plus differentiation of t square is 2t, 2 into 2 4t minus 6 k cap. So this is a tangent vector. Now we have to calculate the first question, unit tangent vector. Just I will write here. T equals, we got the answer, t equals 2t I cap plus 4 j cap plus 4t minus 6 k cap. The unit tangent vector at one point we have to put a t equal to 1, say. So just completing the problem. Now we have to substitute for this. Small t equals 1. At t equals 1, capital T equals 2 into 1 I cap plus 4 j cap plus 4 into 1, that is 4 minus 6 k cap. So t equals 2 I cap plus 4 j cap plus into minus 4 minus 6 is minus 2 k cap. So this is a tangent vector at t equals 1. Now we have to calculate unit tangent vector. Unit tangent vector t cap equals vector t divided by its magnitude. So that is equal to vector t 2i plus 4j minus 2k divided by square root of magnitude 2 square plus 4 square plus minus 2 square. So that is equal to 2i plus 4j plus minus 2k divided by square root of 4 plus 16 minus 2 whole square is plus 4. That is t cap equals 2i plus 4j minus 2k divided by square root of 24. So this is unit tangent vector at small t equals 1. Now another question in the same problem, we have to calculate angle between two vectors and angle between two tangents, and they are given the point at t is equal to 1 and 2. Angle between two tangents at t equals 1 and t equals 2. Now same tangent vector, for this tangent vector you put t is equal to 1, take capital T as t1, and put t is equal to 2, take capital T as t2. So put t equals 1, then this is t1 denoted as t1. T1 is equal to 2 into 1 here, it is okay, I will substitute 2 into 1 I cap plus 4j plus 4 into 1 is 4 minus 6 k cap, or t1 equals 2i cap plus 4j cap minus 2k cap. So in the angle cos theta is equal to, this is the formula, vector T1 dot vector T2 divided by magnitude of T1 into magnitude of T2. So we require magnitude also. Therefore, you calculate here magnitude. This is T1. Therefore, what is the magnitude of T1 is equal to square root of 2 square plus 4 square plus minus 2 whole square. So that become, it is 4 plus 16 plus 4. So that become square root of 24, magnitude of T1. So this is at T is equal to 1, vector, tangent vector, first vector T1 and its magnitude. Similarly, at T is equal to 2, you take this as second vector T2. T2 is equal to 2 into 2 I cap plus 4j cap plus 4 2s are 8, 8 minus 6 k cap. So that is equal to T2 is equal to 4i plus 4j minus, sorry, plus 2k. So therefore magnitude of T2 is equal to square root of 4 square plus 4 square plus 2 square. So that is equal to square root of 16 plus 16 plus 4. So that is square root of 32 plus 4, 36, that is equal to 6. This is magnitude of T2, second tangent vector. Now we have T1, vector T1, this is vector T1, and we have vector T2 and magnitude of T1 and magnitude of T2. All four you substitute in the formula cos theta equals. Next line. Therefore, angle between two vectors or two tangents cos theta equals the formula T1 dot T2 divided by magnitude of T1 into magnitude of T2. So that is equal to cos theta is equal to, this is T1 dot T2, that is 4i cap plus 4j cap plus 2k cap divided by magnitude of T1 root 24 into magnitude of T2 is 6. So that is equal to, this is the dot product, that is equal to, we have to simplify the dot product of two vectors, 2 into 4, 8, I dot I is 1, plus into plus, 4 4s are 16, j dot j 1, now minus into plus, minus 2 2s are 4, divided by 6 into root 24. So that become cos theta equals, this is 16 minus 4, 12, 12 plus 8, 20, 20 divided by 6 into root 24. Still we can simplify, we can cancel 20 and 6. Finally, theta equals cos inverse of this answer, 20 divided by 6 into root 24 is the angle between two tangents. So sometimes they may give the points, 2 points and only one problem, one vector. And sometimes they will give two separate vectors, tangent 1 and tangent 2, they will ask find the angle.